Okay, Assalamualaikum and very good morning everybody. So we move into new topic, okay, similar to liquid chromatography, still using liquid as mobile phase and solid as stationary phase. This is ion exchange chromatography. Okay, so why is its name is ion exchange, and what is the application of this ion exchange chromatography? We will learn all about it in this class. So ion exchange chromatography is shortened as IEC. You will see in the paper sometimes people write IEC, or sometimes people just write IC. So this denotes the ion exchange chromatography. Okay, this is not to be confused, even though it's the same principle with ion exchange SPE. Okay, so ion exchange SPE. So ion exchange SPE is using the same mechanism with ion exchange chromatography, but in SPE we collect the eluate, while in IC or IEC we detect the analyte or the eluate. So what is the application for IEC or IC? So basically anything that is charged, means that anything that can be charged. Virtually everything, right? Everything can be charged except for all those naphthalene, anthracene, and so on. So that means it is used mostly in food and beverage industries. What kind of application? So you can imagine that a lot of compounds in food and beverage are charged. For example, amino acid. Okay, and then we have protein. Protein is the largest structure of amino acid, and most importantly is salt. Okay, salt is of course charged when it is in aqueous solution. So this is very important to IC. And then let's go and see what is the application has been done using IC or IEC for the past few years. So this is a paper in 2017 used in IEC is used to quantitative analyze 6 cations. 6 cation means that's positively charged compound lah, in 3 biodiesel and their life feedstock oils by using IEC. So you can see that this is also used in oil and gas industry. And then we have the usage of IEC for the analysis of magnesium, calcium, zinc, and iron ions. So basically these are the alkaline earth metal and also the essential metals available needed by our body. Okay, you can use IEC. Next one is amino acid analysis by using ion exchange chromatography in plasma sample. Plasma obtained from your blood for bilirubin interference. This is jaundice near. Okay, so where does this IEC falls into the category of chromatography? As I said, it is under the liquid chromatography category, and it is using solid phase as the stationary phase, and importantly it is using resin. So how does resin looks like? Resin looks like your silica gel in the packet when you buy a pair of shoes. Okay, remember the one that is like the telur ikan tu, so that is resin. It looks like that. It is usually yellowish color. So this is in contrast with the adsorbent used in HPLC or gel used for size exclusion chromatography. So resin is used in a column for ion exchange chromatography. Why resins? Because The resins will be functionalized with a lot of charge on its body. Either is positively charged or negatively charged, depending on what application you want to use. Later we will talk about stationary phase. So this is IEC, okay? Okay, so this is how the resin looks like. Okay, the resin will be bonded. Okay, will be bonded with a charged ligand. A charged ligand over here is covalently bonded to the resin. The one that will be displaceable by your analyte is this one. Okay, counter ion of the charged ligand. So if this is positive, this is negative. So this will have electrostatic interaction. So when your analyte comes in, this counter ion will come out. Okay, replaced by your new anion. Okay, this is the one that is replaceable. Okay, this is the one that is permanent here. Okay, so let us look on what kind of a resin will be available for your analyte or sample. Okay, your cation exchange resin will carry negatively charged group covalently bonded to the resin. Okay, that is the other way around lah with that one. Okay, so it will have an exchangeable cations. Means that we can replace these cations. Who will replace this cation? Your positively charged analyte. Therefore, if you have positively charged analyte, you will use cation exchange resin. Okay. If you have negatively charged analyte, you will use anion exchange resin. Why? Because in anion exchange resin, we have anions that to be replaceable by your analyte. Okay. But the resin itself carry a positively charged group covalently bonded to resin. It is the counter ion. Okay. Okay, the detection usually used for ion exchange chromatography is mass spec, because mass spec is a universal detector for ions, right? And also we have conductivity detector. So conductivity detector is also used in HPLC, reverse phase. So you can see that how universal this conductivity detector is. As for the mobile phase, okay, the mobile phase, of course, will not be 100% organic solvent. Will not be 100% organic solvent because you want to strip off the analyte from the resin using charge, right? They are interacting electrostatically, so you need a buffered aqueous solution. Okay, means that you have to put certain amount of buffered aqueous solution, okay, containing a counter ion of opposite charge, okay, in equilibrium with the total charge of the resin. Okay, so if let's say you want to if let's say you want to analyze cation in cation exchange chromatography, so you need to use what kind of buffer to weaken the electrostatic interaction. So what is the charge? So throw your answer in the WhatsApp chat, okay, to see how you understand the acid-base interaction. Ni So, and then I said just now, other than buffered solution, you can also have all organic water miscible organic solvent, because even though it is charged, remember protein is also slightly non-polar, so you need at least methanol to elute the to strip off the or to weaken the interaction between the analyte and the resin. Okay, so ions to be separated usually will compete with ion in stationary phase. That's the problem in IEC, but we have alternative, or we have countermeasure how to reduce this competition. Okay, mobile phase also must dissolve analyte And also it should have a solvent strength that give reasonable elution time for separation, just like other HPLC lah.